Morning.
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 Well, it's your show today. Anything you want to review, let me know.
Well, are there going to be some questions about the names of some people? I see some notes about Keeling, John Holden, and I can't remember which one did the peak peak oil. That looks like that must be Hubbard.
I would review all of those. Yeah.
All right.
So Hubbard is peak oil. Who's Charles Keeling? He's responsible for, just that minor one.
Something about a curve.
Important graph and something about a curve. Gosh, it's mighty important. Something about atmospheric measurements, has to do with climate change, might possibly be the single most important piece of evidence about
the CO2 in the atmosphere is just out of control. That's Keeling.
Keeling is CO2 in atmosphere. He doesn't make claims about whether it's out of control or not. That's the beauty of it. He's just been measuring CO2 concentrations since 1950 something. But there is an alarming pattern to the CO2 concentrations. And we kind of talked about one, I think I phrased it as a takeaway message. It's not just that CO2 levels have been rising, it's sort of about how much they've been rising. Anybody remember the sort of alarming? I'm gonna pull it up. You guys see the curve? Can you see the curve? Okay. So here's, recent days annual lows for the amount of CO2 in the atmosphere. Look how much higher they are than past highs. I- the I want to say the elegance of this curve is that you don't, it's not showing you very much. It's literally it's just CO2 in the atmosphere. It's not complicated. But when you compare today's lows to past highs, I mean, that really shows you that this is a dramatic shift. We're not, you can't count on the Earth's vegetation to just like lower us back to safe levels. I mean, we don't ever come back down. Well, it'll be interesting to see the effect of 2019, 2020 on some of these measurements. You might find a little dip because of the quarantine right now. But generally speaking, I mean, that's just, again, sort of, it's such a strong tool for pointing at the fact that things are changing to unprecedented levels. What that means or why it's happening, you don't even have to get into it. I mean, that's sort of the dramatic effect of this. How can you look at that and say that CO2 levels are not defying anything we've ever known before? And again, what that means from there, that's where you can debate. That's where you're going to get like 3 scenarios. Keep increasing, no change, coming back down. That's typically what we ask our models to do. And then that's kind of up to policymakers. But a lot of the strength of the climate change evidence is because of how simple the measurements are. And it's not just that CO2 levels are rising. This is, and so if you think about, well, how are farmers going to plan for that? It's going to cost us some problem solving, some new stuff. That's all. That's the Keeling curve. So that's one of those things. I know you don't believe me that you're going to be at cocktail parties and people are going to talk about that, but you're going to hear this again. You're going to hear it again. I promise. Charles Keeling. Who else? Oh, who's John Holdren? He's only come up like 3 or 4 times in the semester.
Didn't he help write IPAC?
He did. He did. Anything else?
He in charge of something in the government with climate change and like a big part of the government. I know that. Like he's a
He used to be in the cabinet for the Obama administration. I'm pretty sure both terms.
okay.
He was a director of science. Now he has, I'm not sure if he's currently there. He has served in the past as the head of the intergovernmental panel on climate change. I just mentioned that because that kind of propels him past the national stage. He has a very international role with climate change. And again, if you just get bored while you're self-isolating, I highly recommend watching his testimony to Congress on climate change. Take your pulse or your heart rate while you're watching it. It's not uneventful. Guess we talked about T. Boone Pickens.
Was he the guy that like didn't he run an industry, but he supported like the idea of that there was climate change, even though people in his industry don't?
More like peak oil. I don't know how he feels about climate change particularly. Um, yeah, he was a huge oil magnate. Like in the 80s, I think he ran BP's hedge fund kind of thing. Yeah. He was like the oil guy. I think he was really known for corporate raiding too. So he would buy up smaller, like coal and oil, and combine them. But recently, the past 20 years, he's been moving and imploring the fossil fuel industries to consider moving and reinvesting in wind. I think he's into more than that, but he's known because he wanted to build what would have been the world's largest wind farm in our mid-Atlantic jet stream. So yeah, we just talked about the remarkability of an oil, like the quintessential oil guy is now shifting to non-fossil fuels. Because it's not as though in the 80s when he was in the oil industry and like running BP's hedge fund, it's not as though he didn't know about peak oil, because M. Hubbard King came out with that in the 70s. So, they had it, but it's, I guess with T. Boone Pickens, it seems like you can see how long it took him to get his head around it, to accept it. And the wind thing, I don't remember it going well. I don't remember him being received well. I think there was like a New York Times article that proclaimed him dead, dead in the water, proverbially. I don't, it's like if someone like that can't lend some good credit to the idea of peak oil, it's, you can see how resistant our relationship with fossil fuels is going to be. I don't remember I don't remember any other names. Is there anything on like the terms and concepts from the chapters that I listed? Remember anything from water?
So do you consider hydroelectric power renewable or non-renewable?
Considered renewable, but you know, it has different different methods, with different techniques. So the renewability, as usual, is kind of like this gray area of choices.
So does that have to do with the point that we've already dammed up just about every major river that can be used? Or there was something in the book about that, that it's kind of peaked as its amount of dams we can build?
We have, yeah, there are some major rivers that no longer reach their source, like the Colorado River, because we've dammed it so much. So water, you know, like, well, like all renewable resources, it can be more or less renewable. And yeah, we have kind of reached the point where we're seeing depletion. Let's see, I think your textbook talked about depletion on the surface, because it featured, one of the features was that Aral Sea in Eastern Europe, where it gets depleted for the Ukraine's farming, which is a huge breadbasket. And that one, there was one season that was, I suppose, where the replenishment was a little low, like they weren't getting rain as much, and the lake depleted so fast that some watercraft got stuck like overnight. So they have I think the book has like this sad little picture, this like craft being stuck. And then not just on the surface, but in groundwater, we're seeing depletion of our groundwater resources. So we've talked about the Ogallala and the southern part of it that reaches Oklahoma and Texas, and how they've hit seasons where they've run out of water and had to truck it in for drinking. And that was like new maybe about the last decade, 2010 or so, somewhere around there. So it's only renewable, yeah, if it gets renewed. And some of our choices in the conventional history of ours, not so renewable. There's also the difference on whether you're like, you know, you can pump groundwater up to use it for hydroelectricity, but that would cost you the energy of pumping it, because you'd be going against gravity. And then there are times where you can let it run downhill and there's no energy input. So that's a difference between some of the techniques. And then there's kind of a difference on how you're using the water in the hydroelectric power source. If you're just running the water to, you know, if you have enough flow that you can just use the water to turn the turbine, that's probably more renewable, because the water can go right back in. It's kind of gray water at that point. Like you can't use it for anything else. Kind of want to just have like a loop, because once it touches the turbines, it's going to pick up like, you know, lubricants and just industrial goop. And you can't like just return that to the river for people to swim, like fish in. So that's a little different. You know, like whether the water comes in contact with the turbine directly, or whether you're just, you know, you could use hydroelectricity in a way that you use the water as steam. You know, if you've got a way to, but you're gonna, again, that's a little less renewable, because you're gonna have to have a heat source. Hydroelectricity is such a like top alternative, conventional alternative. That one in nuclear. We have lots of different techniques, different choices you can make, different strategies, different ways of dealing with the waste, different infrastructures in place. Just because those two, we have a pretty long history with those two alternatives. I'm just thinking how weird it is that Hoover Dam, which is one of the first real big reasons why the Colorado no longer reaches the coast of California, because that's a huge dam. How funny that like one of the hugest dams in the world's history is in the desert. That's weird, right? That's weird, right? I mean, you would have to pool it in order to let people live there. But so by damming it, and because Hoover Dam is so huge, they can get the Colorado River water to people who otherwise would live too far from the river to really use it or make use of it. And so that was terrific. Like in the 1800s, early 1900s, that was terrific to give people electricity, from so far, make our grid bigger and bigger. It allowed for people to like live where they want. And it was just different when we weren't 7 to 9 billion people on the planet. It was just different. Must have been nice. I always wonder what LA looked like in like 1800, but it was beautiful. But now, California agriculture is like the other reason why the Colorado River runs dry. Hoover Dam plus all of the irrigation for the salad bowl of California. That's a lot. It's a lot of water right there. I think we talked a lot about dam removal and like the benefits. Natural flooding cycles are actually less devastating to like homeowners and ecosystems. It's about how fast water ecosystems, freshwater ecosystems like a stream or the sides, the riparian vegetation on the shores of a river, how fast they return back when you remove a dam. It only takes like one growing season. You kind of, you replace the economic benefits. Usually when a dam is created, it's because it's got all these economic advantages, but after time passes and the dam needs maintenance, your developments may have shifted, it just may not be where people are living anymore, so you don't have the demand anymore. Sometimes the cost of the upkeep of the dam, it's outweighed by the benefits you get by removing the dam, because if you get fishing, any kind of recreation, if you like replace natural flooding cycles, it could actually make it better for housing developments. You could, if you remove a dam, you could have a return of things like fisheries, like other sources of revenue that use that water system. It's just the difference between having it dammed and not. When you dam rivers, the benefits usually like all human. When you remove a dam, you keep human benefits usually, but you kind of get like a broader spectrum. Like, again, if you return an entire ecosystem and then people want to hang out there, and you can charge for like fishing licenses or boating fees and stuff. Again, you still have human benefit, but again, it's a broader benefit of other species and other parts of the ecosystem as well, which then returns the benefit back to the humans. So it's kind of gets like a deeper benefit. We are definitely in the phase of removing dams. It's just a lot of little dams. Every time there was a housing development between 1960 and 1980, usually it came with a little dam, and it's housing developments would be made around that dam. And that was just, it worked, made sense till we started running out of water and other things. And the dams, it's a lot to ask of a structure to be a dam or a levee to hold all that water back. So like every day that the dam is doing its job, it's corroding a little bit, the pressure of the water, you know what I mean? So it's, from a financial standpoint, you're going to have upkeep eventually. It's like inherent costs. So it's had a lot of support for the dam removal.
One time I used to live right across from the Kokosing Reservoir, and I saw a truck that was going across the top of the earthen dam with like a pile driver, and I think it was doing sonar readings to see how the earth was holding up
Yeah.
through there. And there are a lot of little tubes sticking up along the earth dam, and I think there's sensors in there and stuff. There's a lot that the Army Corps of Engineers were doing. It's been almost 20 years ago now. I don't know if they're still doing it or not.
Probably. I imagine you have to just knowing usual regulatory demands. You know, you're checking it you're making safety audits like every month, every year, after certain kinds of events. I mean, we're pretty bureaucratic about checking us. Once you get the Army Corps involved, it just doesn't get any bigger than that. It really doesn't get any bigger than that. They do the biggest work and the most like landscape altering. And again, I mean, I like the example of Hurricane Katrina because the hurricane was like one thing, but the fact that it was too strong for the levee, and that the Army Corps knew that. And the Army Corps did not want it to be that way. The Army Corps recommended making it stronger. There just wasn't enough in the budget because New Orleans and Louisiana are not famous. They're not famous for their riches. It's kind of the opposite. They're one of the most impoverished states. And they get no money. They get no revenue from the offshore drilling. Nothing. That's not the way the system works. So it's especially weird. They get like the short end of every stick. They could. So there just wasn't money. It's not like somebody said, I don't care. It's just, there was just no money. I don't think the politicians and the government that were in charge of Louisiana at the time wanted it to be that way. I don't think the federal government wanted it to be that way. I don't think they are, but you know, we had never seen a Category 3, or it had been so many years since we'd seen a Category 3 storm. They thought, well, you always balance. You balance what you've got, known risks. I gotta fix my dog. Beta.
Come here.
My video is really glitchy. Are you guys having problems, or is it just on my end?
Mine's doing okay.
Yeah.
Must be just my end then.
Sorry about that. Dog freak out. What else?
What's the term from chapter 20, novel biofuels?
Oh, look at them. So 20 is conventional alternatives. So the novel stuff. Really missing the privacy of our classroom right now. So it's probably like the, so chapter 20 is what, nuclear, hydroelectric, and biofuels. So the novel ones are like the newer ones that you're probably familiar with just from life. Ethanol. What else? Trying to do it from memory. Your book doesn't talk about corn cob stoves, but like anytime you get just away from burning wood or animal dung, those are not novel because humans have been doing that pretty much since we figured out fire. But to take mass amounts of corn and turn that into fuel, that's novel, that's new, that's why they call it that. What am I forgetting? Oh, biodiesel would be another one, like that you could take leftover like French fry grease. You do a little alteration, you do some alteration to a diesel engine. I don't think it's little, but it's not, is doable. Let's just say it's doable. And yeah, you can run it on like leftover grease is the one I think of, like a fry grease, because like a lot of time, sometimes kitchens or restaurants will pay people to take away the used French fry, the deep fryer grease, and they use it to run, equipment. I'm pretty sure this is just like from an Oprah episode of the Oprah show, but I'm pretty sure Daryl Hannah, the actress, she does this. McDonald's pays her to haul away their used French fryer oil. And she's got like land that she maintains. I don't know if she farms it, but she runs all of her equipment off of that grease. So she gets paid for the fuel that she uses to run her land. It's pretty novel. I think we talked about Loyola, how they do that, how they process some biofuel. The students do it in the lab. And that's also novel biofuel. It's just any of these newer sources. The algae that we talked about, when we talk about BP, right, and they're funding some research to turn algae into fuel, that's novel. Again, just because it's newer, I mean, humans have been burning biomass and biofuel forever. That's kind of the original fuel source, really. But again, to turn it into ethanol or convert an engine for biodiesel, that was really novel. Those are the only two I can think of, or three: algae, or that's all the book has. According to your textbook, algae grows much faster than terrestrial crops, like corn, and can be harvested every few days. So it produces much more oil than other biofuel crops. Oh, your textbook also says that the Loyola project, the students produce the biodiesel from the waste vegetable oil from the dining halls. Any other terms like that that stand out you want to go over? The difference between passive and active solar energy. Got that? Which one does COTC, the Knox campus, which one does that building feature? Active or passive?
Is the only active using photovoltaic cells, so then passive is just absorbing the heat and sunlight, right?
Mm-hmm. You'll put more windows in, you'll face those windows to maximize sunlight. Use building materials that, yeah, absorb the heat and then can re-emit it, give it off. Mhm. So between passive and active solar power, which one would get you into trouble with like consumer preference for aesthetics? You know, like what people want to see on the landscape. We talked about that being a huge detractor to new alternatives, right? Just consumers not wanting to look at stuff. Which one between passive and active solar causes consumers to complain about the landscape view?
The active one, because panels and people don't like them for some reason.
The panels, and then if they use like mirrors, a field of mirrors to, you know, concentrate the light onto the panel, that's a huge amount of land. Yeah, panels or anything involved with the panels. So yeah, active is usually what people complain about. Usually consumers prefer passive solar features, like just if you have a building that has more passive solar features than not, people prefer windows usually. We actually use a lack of windows to torture humans. That's one way you can mess with somebody's like sense of what time of day it is or whether it's night or day, is to cut them off, you know, from outside. We just have sort of like this natural inclination to like windows. We want to be inside, but like pretend like we're not out. We're outside. We want both. We want to be outside, but you know, not have the bugs or the temperature. I guess some people hate birds singing. Just want to cut that off. Zones of a lake. Went over that. Difference between global warming and climate change. You good about that? We talk about spheres of the atmosphere. Where the ozone layer is, what happens when ozone develops in the troposphere, becomes a pollutant.
So where is ozone supposed to be then? And it's not a pollutant? I forget which one is that.
The stratosphere, where the clouds are. That's where the ozone layer is. But when ozone's generated down here, it's a very strong respiratory irritant. And it's a pretty inert chemical. There's that weird molecule with the three oxygen atoms, and that weird triangle shape. So it's not only is it an irritant, but once it's in you, in your lungs, it'll just kind of keep pinging around, causing damage. It's really nasty. So anywhere you have really large electrical currents, so lightning can make it happen. Lightning is really more how the ozone layer repletes itself, but it can happen down here in minor levels. Down here, it's usually around really large industrial-sized transformers that are close to the source, the power source on our electrical grid. You can get some ozone, something about copy machines, something with the toner, something where the electrical current hits the toner, something about the electricity that can generate small amounts of ozone, which isn't a big deal unless you have the copy machine in an enclosed cubby or like a little nook. That can be like a work hazard. You're not supposed to do that. And then ozone can form from a particular set of circumstances with car emissions and a high temperature and a lot of direct sunlight. It can kind of be in the mix. Usually it leads to something like photochemical smog, kind of like Los Angeles, just to pick on them. They're kind of the main example for that kind of smog because they have super high levels of sunlight. It's not a problem for Ohio because, we get those beautiful gray days. So there's no UV to interact with our car emissions. Yay! I think we talked about like some different greenhouse gases. CO2 is the big one, but what are some other ones?
Wasn't water one of them?
Water vapor can be a greenhouse gas.
Ozone, carbon dioxide, nitrous oxide, methane.
Methane. How about ozone? I don't know if it traps heat. It might. Usually the ozone and the nitrogen oxides we talk about with air pollutants, outdoor air pollutants. That was on our list. It's like carbon monoxide, sulfur oxides, nitrous oxides. Lead, particulate matter, little air, just little tiny bits of solid suspended in the air. It's like soot, Sulfur dioxide is all coal. That's a coal industry. That's mostly associated with coal. Everything else is emissions. Carbon monoxide, nitrogen oxides, particulate matters. There's probably VOCs, volatile organic compounds, just from the fuel. And then lead is not an issue now. Where lead is an issue in the environment is left over from when lead was in our fuel, which it's not now. We don't. So that's a happy story, because the minute we took lead out of gasoline, the atmospheric levels of lead came down almost immediately. The problem with lead is that it's a heavy metal, so it doesn't like to react. So it likes to hang out. It's very persistent. So the lead that we pumped into the atmosphere by burning leaded fuel, it came down with rain and just hangs out in the soil. So the legacy of lead now, we deal with sometimes. Sometimes you'll have issues. They'll build a children's playground, and the soil is heavily leaded. It's got a lot of lead residue, and you know what kids like to do with dirt. Some ingestion there, but it's left over. It's not. It just kind of points out how some of these pollutants, once you put them out there, it's really hard to get them out. But lead, we definitely, it used to be, what we have in the environment is mostly from leaded gasoline, which is, it was just an additive, it reduced engine knocking, this noise that was supposedly didn't have anything to do with the performance of the engine. So it wasn't a big deal to take it out of the fuel. It was just like a consumer preference. So they say.
I've heard that some of the highest concentrations of lead is between the street and the sidewalk in that grassy area in inner cities. Is there any way to get that out of the soil, or what do they do when they find out that there's high concentrations of lead in dirt around playgrounds or around places? How do they take care of that?
You excavate. What do you do with this? Like you can go in and like grab the soil, right, and truck in new soil. But what do you do with that leaded soil now? We have really sophisticated ways of getting the lead out of the soil, but then what you do from there is a big question mark. We can use, certain plants are really good at absorbing nasty compounds right out of the soil. You can clean soil and water. It's called phytoremediation. And you can, like, it's sort of like a cover crop. And we know that you can clean up like areas that were like really heavily industrialized, but now have been returned to like recreation areas. But what you do with that plant matter, once the plant absorbs the lead, it puts it in the vacuole of its cell. I don't know if you remember from your plant biology, plants have a vacuole, a really large pocket. They can just store stuff. And it can be nasty stuff, but if they put it in that vacuole, it doesn't circulate and do damage. But what do you do with that plant now? Because if you burn it, you're going to release the lead back up in the atmosphere. You sort of start the whole thing over again. If you bury it, you got to make sure it's never going to leak. And then where do you bury it? Because nobody wants that on their property. We haven't invented a storage container yet that won't eventually leak. We can get you decades down the line, but eventually it's going to leak. So nobody knows really what to do with it, you know. There are some in inner cities. Oh my God, there are some areas, some neighborhoods that are like in between a freeway and a railroad. And I mean, you'll just find the highest levels of lead, and they excavate. I mean, they come in with hazmat suits and they just pick it up. And then I don't even know. You pay somebody to do something with it. My guess is we've been sending it to China until recently, something like that. I don't know. Nobel Prize waiting for you if you can figure that out. Convert lead into a novel biofuel that doesn't pollute the environment. Most of the outdoor air pollutants, they are car emissions, and it's the more inefficient your engine, the more you get the pollutants, because it's usually a result of inefficient combustion. And then keep in mind that combustion is never 100% efficient. Like, you can write out that formula on a piece of paper, you never get that. And you know how cars work. They start losing their value the minute you drive them off the dealer's lot, because we know that the efficiency of the engine like wanes with time. Just gunk builds up, parts wear down, different temperatures can have, your engine's not usually as efficient in the winter as it is in warmer months. Of course, that not when you get into the like July, August, because your engine's going to be inefficient if it's really hot too. It just want a sweet spot like 50 and 80. So we're always really getting a lot of these outdoor air pollutants from driving. It's just kind of like comes with the territory. If like the atmospheric scientists had their way, you would never run your engine idle. Because your engine gets really efficient when you're sitting at a stoplight. Your engine is designed for maximum efficiency when you're moving. Yeah, air coming in to help the combustion.
Like, turn off their engine if they're at a stoplight.
Notice a lot of engines now they do that automatically. you know, and then when you hit the gas, they, you know, turn on again. Of course, that's another moving part. It's another electrical part that can break down. You know, I mean, it's just, there's no perfect solution, I guess. It's just what is. If you're gonna combust anything, it wouldn't matter if cars ran on, you know, biofuel. You still get some of these products. Supposedly the idea with biofuel is you get less. Also with biodiesel, I hear it smells like food. You know, instead of the smell of normal emissions, you know, it smells like French fries. So some of the VOCs are more pleasant. But you're still, I mean, it doesn't matter if you're running on biodiesel, diesel, gas. You're going to be putting out particulate matters, VOCs, a little bit. You know, the reason why we call them nitrogen oxides, the NOx, because it's so volatile and it goes through so many changes because, you know, combustion. You're burning molecules and they're just like constantly changing, and then, you know, the heat of combustion just like is still forcing molecules to change all the time. So the NOx is because the nitrogen keeps picking up more and more oxygen. Sometimes sunlight kind of can cause some chemical synthesis. It's hard to measure exactly what's coming out of a tailpipe. It's changing all the time on you. It's hard to measure cars when they're in motion. It's hard to stick a sensor up a tailpipe if someone's going 60 miles per hour. So again, even when we're measuring them, like when you go to get your car emissions tested, you're sitting idle. Your engine's not right there. You're not at maximum efficiency the way it was designed, you know. So there is no such thing as zero pollution here. They're just trying to get you to identify what the nasty components of combustion, large scale combustion is, particular fossil fuels, because that's, you know, the majority of our fuel source. And then sort of identifying how we lower them. We have to make choices. We make choices like in the summer, we lower rates of combustion. We dictate what hours of day or which neighborhoods on which days of the week can mow, because that's in the summer. In the summer, because you have increasing sunlight, the air pollutants, you know, they get exacerbated. So like in cities, particularly where they have like really heavy smog days, they limit the amount of combustion. Not so much driving, because it's really hard to tell Americans when to drive and how to drive. I mean, we just don't like that. Driving is like this emotional issue that it's different for us than other countries. Other countries aren't quite this attached to driving as we tend to be. But we will limit like small cycle engines, you know, leaf blowers, mowers, weed eaters. Sometimes we put rules on that. But nobody expects all of these outdoor air pollutants to ever disappear. It's not about getting them back to zero, even with the lead. I mean, it's too tall order. What are you gonna do? Get everybody to stop driving? Get everybody to take public transit, take a bus? Do you know how people feel about buses? Not good. So we just regulate with all pollutants, whether it's water, air, soil. We regulate how much. We base it on that LD50. And you find the LD50 and then you just pull it back. So it's not a presence absence with pollutants. It's how much. Right? Gosh, I'm just realizing all of what we just talked about was that's human sourced air pollution. There's tons of natural sources of pollution. Volcanoes erupting, dust storms, tornadoes can, any kind of storm, really. Anytime you have particulate matter up in the air, high levels of the troposphere or make it into the stratosphere, it's fires can cause, really big wildfires cause air pollution. So it can be irritating. When you talk about the spheres of the atmosphere, you know, the troposphere, the stratosphere, it's all round, right? Because it goes around the planet. So the biggest issue with air pollution is that usually the emitter is not the one to feel the effects. Because if you put something up in the troposphere and it gets up into the stratosphere, it's going to move. It's going to get blown around. And this, the spheres of the atmosphere don't really mix much. They tend to stay pretty separate. They have like a density and composition difference that keeps them separate. A lot like the zones of the lake. I think we talked about the thermocline, that 4 degree, where the water is 4 degrees, it's the most dense. So it protects the integrity of the littoral zone on top and the profundal zone on bottom. And for every sphere of the atmosphere, you have the same thing. We have at the top of the troposphere, there's a tropopause, which is just this boundary that the stuff in the stratosphere can't really come down, and the stuff in the troposphere can't go across. It's because it's like a density barrier. It's not a physical barrier, but it's not a visible barrier, but molecularly speaking, it's a barrier. It's really a pause. And then at the top of the stratosphere, you have the stratopause. And at the top of the mesosphere, you have mesopause. And so if a pollutant gets up into the stratosphere, it's going to stay in the stratosphere. It's not going to go out to outer space, right, necessarily. And it's not going to come back down. It's going to spread. And so a lot of the first, the developed world, where most of our industrialization is localized, is typically the source of higher concentrations of these air pollutants, just, because we have infrastructure and we have cars and we have a certain standard of living. So everybody's got their own car and got more cars on the road, and more people, more developments means more power source, which means more pollutants. And a lot of those pollutants they move around the globe. So they're felt by people who live in more developing nations. And they can sort of sometimes get the pollutant, like they'll get the particulate matters in the rain, and they get like the rain that leaves crud on the crops, or the acid rain levels. And that's usually how air pollution gets you into like socioeconomic ills. Like, here's an example. I'm picking on Los Angeles today for some reason. I used to live there, so I feel like I can do that. Los Angeles is on the coast, so that they've got the ocean winds coming off all the time. The beauty of Los Angeles, the city, is that it's like 75 all the time. It's never too hot. It's never too cold. You might need a sweater at night. It's mild. But it's also known for its driving, right? Like, the joke about Los Angeles is people would drive to the bathroom if they could fit their car in the doorway. It was literally, there was a legal conspiracy. Like, GM and Firestone were prosecuted by the way that Los Angeles was designed, because they dismantled a lot of public transit. They really pushed private car ownership and then built that freeway system to be like no other. to make driving just as fluid as could be, just meant congestion. Now as the city's population grew and Southern California became more and more developed, those freeways are gridlocked during rush hour. And rush hour in the afternoon, that's when you're going to get the highest levels of sunlight, and you're going to get your highest temperature. Our temperature, temperature tends to peak out around 4 p.m. So for Los Angeles, that's, you got all these cars sitting idle on the freeway at 4 p.m. It's just a lot of smog, right? So in the, I don't know, after 60s, 70s, 80s, they became known as like the smog city, right? It's kind of like where we learned about smog, where a lot of our policies developed. But it only takes like a good breeze and that smog blows inland. So it's not really like the residents of Los Angeles, it's not their problem. It's if you live in the valley or what they call the Inland Empire, which is in from the coast and then surrounded by mountains. So the smog gets trapped for people in like San Bernardino. They get to feel all that smog from Los Angeles. They live with it. When you go up to like Big Bear Mountain and you come back down, you're gonna go right into LA's smog, even though you're really far inland from the coast. So where the air pollution is generated is not typically where you feel the worst of the effects. We talked about halocarbons, chlorofluorocarbons. I think we talked about CFCs more than any other one. And their role in depleting the ozone layer. From refrigeration, styrofoam, aerosols. There used to be like campaigns against hairspray because of they were a source of CFCs. And what makes them really terrific in industry makes them particularly hazardous, right, in the atmosphere, because the CFCs undo ozone. They can take apart that ozone molecule, and it doesn't do anything to the fluorocarbon. So it can just kind of keep going around and undoing this molecule and undoing that molecule and undoing that molecule. And we pumped enough into the stratosphere that it created the ozone hole. The ozone hole was over the pole, the South Pole. And that's, again, because where the chlorofluorocarbons were being generated was not near the South Pole, but because it was in the stratosphere, it's going to move, and the natural, the electrical magnetic field of the poles tends to attract junk that's in the atmosphere, pollutants, particulate matters. So those CFCs kind of concentrated at, I don't know why the South Pole and not the North Pole. I'm sure there's a hole in the North Pole too. It just isn't as large. Usually the ozone is being depleted and then renewed, or renewed. But somehow we got out of balance and we were depleting more than could be renewed naturally by cycles of lightning. Not sure how much lightning occurs over the poles anyway. Just not sure. Any issues with some of the fuel technology, like difference between fission and fusion, which one we do? Just overview of how it works. I don't think we got too deep into stuff, but understanding how much more energy you get with nuclear energy compared to fossil fuels. I mean, understanding that enormity, remember that reaction is so high energy that most of the work we do is in controlling it and slowing it down. That's ideally how we prevent things going wrong. Understanding that all of that is just not worth anything, because the 1% of the time that things go wrong with nuclear energy, it's like so devastating. I mean, compare Chernobyl to the deep horizon oil spill. I mean, you don't want either to happen, but if you had to choose, I'd probably rather the oil spill because I'm not directly affected, probably. That's selfish, but the idea of a nuclear meltdown in West Virginia or something, that's probably going to affect me. You too. Me meaning you. So darn it, if we could just figure out cold fusion, we get around to all that. Remind me where we do see fusion. Because technically fusion does run our planet. How can I make that statement? How can I say that? Fusion runs our planet.
Is it the sun then?
Now you're thinking like an environmental scientist. That's familiar, right? Sun is the ultimate power source for us, right? Wouldn't even have fossil fuels if it hadn't been for photosynthesis at one point, right? Any questions about like oil refining and the amazing amount of products that comes out of that? I mean, everything from the stuff that makes candles to the plastic bags you get at Kroger to the oil that they put into your car to the gasoline you pump into your car, jet engine fuel. A really good example of how much infrastructure and how sophisticated we have become with our fossil fuel technology, that we can get all these products. I mean, plastic used to be nothing but junk, used to be just the waste product from refining. And then we learned how to make plastic. Thank you, Dow Chemicals. I mean, that just revolutionized everything in the 60s. I'm going to make another movie reference, especially for Lauren and Claire, because Darren, you probably have seen The Graduate, I'm guessing. You should watch The Graduate. That's in the canon. And there's a hilarious scene. Dustin Hoffman has just graduated college and his parents throw him a party and it's awful. And he's having a very difficult time enduring all the advice from the adults. And one guy just corners him and he's like, I've got one word for you. Plastics. And he's like trying to convince him he should go into like the plastic business or whatever. And I think back in the time in the 60s, like that was laughable but oh my God, plastics. And that was nothing but junk that came off the refinery process. But we've gotten so sophisticated that we can even take the waste of oil refining and turn it into an entire economic industry of its own. It's remarkable. We talked a lot about fracking, right? So directional drilling, fracking, same thing. Fracking is a type of directional drilling, just it targets the gas that's trapped in shale. But if you had a different type of substance and a different type of substrate, it would still be directional drilling if you just drill down and then just anything that's not straight down, any kind of bends or curves. Usually it's to the side. We just talked a lot about fracking just because that really impacted Ohio. I'll just say bigly. Affected, whether it's good or bad probably depends on who you are, where you are. For our local natural gas companies, it was probably a pretty big boon for a lot of homeowners who were able to not get screwed on the rights. It probably would have been good. But we talked about some of the, the hazards with the brine, the very liquid that they pump in to help get the gas out. It's, we identified that it's volatile enough if it gets into your water source. We watched that movie where the guy was lighting his faucet water on fire, Gasland. We talked about the radioactivity of the brine. That's probably the scariest, I think. I don't know if we talked about this, but another consequence of the directional drilling, particularly fracking, is seismic events, also known as earthquakes, but we don't call them that. We call them seismic events. I don't know why. But it's very important litigiously. And if you went somewhere like city council to talk about fracking, you want to say seismic events, because if you say earthquake, they're going to be like, oh no, you can't call them that, and it'll derail the point, So seismic events that have been correlated with fracking. I don't think anyone's admitting cause, but they happen at the same time. So maybe the fracking just calls on the spirits of the earth gods. Doesn't cause it, but it just indirectly aligns. I'm completely being facetious, guys. Fracking causes seismic events. Turns out when you drill, it affects things on the surface. Turns out when you do that. Not when you suck things out, it affects things on the surface. I just want to, I don't mean to point fingers. I just want to point out that there's just never anything that's all good or all bad. Everything's always mixed with environmental stuff like this when you want to harvest environmental resources. Fracking was really fueled by a very well-intended movement to get off of oil and coal. So it's very common. It kind of, we started fracking before we really knew all of the dangers. I don't think anyone was able to forecast things like seismic events, or it really sounds like all signs point to the radioactivity of the brine being news to some, and then just like not measured, like just not thought about. That's because we went and proceeded before we like studied it, and a lot of times we complain about the bureaucracy of getting like new techniques approved, and it was really some of that bureaucracy was holding back technologies like solar and wind and geothermal, and some of the newer alternatives. And fracking kind of came in the door with those. Kind of all happened at the same time. So again, it's just it's like a lack of foresight, but I'm not even sure it's a foresight you can have, especially when you move that fast. Fracking really is one of those harvesting techniques we've learned on the fly. And I don't even know if we talked about some of the like legislature's role in this like I don't know if we've talked about eminent. Do you know what eminent domain means? Let's just put it this way. Stephen King wrote an entire story about eminent domain once. It's in the book called the Bachman Books now. The government can come along and seize your property as a property owner if they can demonstrate that there's like a public benefit to that property. Your property rights mean nothing. If they determine they can put a dam, and that dam will generate either so much money or so much money for so many people for so many years. If they need to build a freeway, and that freeway is going to be the impetus for a lot of economic development, or fracking. Like fracking, they can go on. This isn't like, you don't have to worry if you live in town. It's not going to happen in your backyard. This is like a lot of native reservations. Right now, we're seeing the Bureau of Land Management, who BLM is in charge of all our national parks, enforce things like Yellowstone National Park, right? We're starting to see the BLM relax rules and letting drilling for fossil fuels onto public lands, and they can do that with eminent domain anytime they need to. So it's not. Sometimes it's homeowners. You guys know how you can do that back way? Well, it's probably not back way anymore, but you can take 229 like all the way to 71. You go through Marengo. I think that little bit you're on a different road, maybe 61 or something like that. You just jog through Marengo. It's always talked about to build an on-ramp where you didn't have to do that. Built the on-ramp right in Marengo, so you wouldn't have to go through, just to make it easier. But there are homeowners who would have to lose their land to eminent domain in order to do that, right? I would say eminent domain is one of the huge ways you get into the socio-political issues with any kind of harvesting. If you're a homeowner, or let's say you're a nation of native people on a reservation, like recently we've seen issues with the pipeline leaking, or they want to build a pipeline, it goes right over or right through your water source, and you lose because of eminent domain. I don't think people would feel any better if they had wind turbines forced on them. You know what I mean? We sort of feel like the wind turbines are like a better energy source because it gets you out of some ills. But if you used eminent domain to build a wind farm, and took property from individual property owners, you know, to do that. I think you'd still get into some issues because, again, the American sense of ownership is it's strong. The force of property ownership is it's just in our culture. It's, you know, manifest destiny. So, when eminent domain happens, it doesn't go down well. You know, it's usually a fight. Again, in the Bachman book, Stephen King wrote a obviously scary story about somebody who decided to take on the government. It's not as famous as The Running Man, but it's in the same collection. Why am I always talking about popular culture? It's like I'm obsessed or something. Anything else? I don't mean to keep you longer than class time. So Thursday, if you want to Zoom with me, we'll just log in like this, and then you can share your screen the way that I do sometimes with that share screen button down at the bottom. That's all there is to it. 50 questions. I think people are averaging around 30 minutes, 45 minutes for this kind of a multiple choice matching Moodle exam. That's what I've noticed. And if you can't do it during class time, you can either make an appointment with me and I can handle the recording of it, or you can log on really anytime you're ready. Because if you want to do it at like 11 p.m. at night, I can't help you. I'm not awake. You can record yourself. You can turn on the Zoom. You can start your own Zoom session, share your screen, and then record, and then just do everything like normal. Just log into Moodle. The exam will be like a quiz link, so it'll probably feel like your lecture and lab quizzes. And usually the record buttons with the other controls right at the bottom. And then you can send me you can, if you do it that way, you can, the minute you stop the Zoom session, it'll start converting the recording into an MP4 video file, and you can upload it into the Dropbox for exam 3, which is like when I put up the information about the exam, that's actually a Dropbox. So you can like load it in there. But again, if you just want to forget all of that annoying stuff, you can log in Thursday regular time, and I'll take care of that. Typically I just sit here like we're regular, like the regular classroom, you know, and you, yeah, it's just instead of scratchy on the paper, it's clicky because everybody's, but you can mute it. You can. And then Lauren, you and I have our own appointment at
11. Will that work?
after class, right?
Yeah.
Yeah. Okay.
Okay, thank you.
Yeah, no problem. I don't mind. No problem. Any other questions?
I don't think so.
No? Okay. Well, you'll email me and let me know, right?
Yeah.
When it comes up. I've been working on the exam, and I've really been focusing on like the stuff that's covered on the homework, the lecture notes, more the homework, and the lecture quizzes. Okay. And for the fuel chapters, with since I gave you all those terms and concepts, I really only focused on the ones we talked about. We covered a fair amount today. Peak oil, a huge chunk of it. Can't get too much else. All right, well, I'll be back at it on Thursday. And again, you can log in even if you're not ready and just be on Zoom with me if you have questions, and there's plenty of time for the exam. I don't think it'll take the whole class time, the whole 80 minutes. So I think you could feel really leisurely about it on Thursday. You log in.
Sounds good.
Okay. See you guys.
Bye.